Which of the following statements about mixtures is true? A. Mixtures have a fixed composition. This is not true because mixtures can be a mixture of two or more pure substances simply mixed physically, and they can be mixed in any proportion. Sodium chloride, and you dissolve it in water. For example, you have two compounds. There's not going to be any chemical reaction between the two. It's just going to be a uniform mixture of sodium chloride in water. And you can mix them in any proportion. For example, you can dissolve 5 grams of sodium chloride with 100 grams water. You could dissolve 10 grams in the same 100 grams water. You could keep adding more sodium chloride. Differences in physical properties are used to separate components of a mixture. This is true because the components of the mixture retain their physical properties as much as the solubility of sodium chloride will allow it. You can dissolve them in any proportion. And you can separate the components based on this difference in physical properties like melting point, boiling point. Components of a mixture are chemically combined. They are not chemically combined. If they were, you would not be able to use physical methods to separate them. Mixtures can be represented by a chemical formula. No, you cannot represent a mixture by a chemical formula because they can be combined in any proportion. They don't have a fixed composition. So you cannot have one particular chemical formula to represent them. Which of the following is not a homogeneous mixture? A mixture can be homogeneous or heterogeneous. Homo means uniform. So homogeneous mixture is a uniform mixture where the components are mixed evenly, and a heterogeneous mixture is a non-uniform mixture which the components are not uniformly mixed. Oil and water, we know that they don't mix evenly. Oil is less dense than water. It forms a layer and floats over the water. So this is hetero. Stainless steel is an alloy. And alloys are homogeneous mixtures of metals with other metals or non-metals. They're melted, mixed, and then cooled to get a uniform mixture. So this is homogeneous. Ethanol and water, they mix in every proportion. So that's homogeneous mixture. And unpolluted air without any suspended particles is also a homogeneous mixture of gases. So the answer is A. What is the name given to the change of state represented by the following equation? So here we see that there is no change in the chemical formula, so it's not a chemical change. There is a change in state, however, so it's a physical change. So know this, solid to liquid is called melting or fusion, and solid directly to gas is called sublimation. Gas to liquid is called condensation. Liquid to solid is called freezing. Gas to solid is called deposition. Here we have gas to solid, so that's deposition. Bromine has a melting point of negative 7.05 degrees Celsius and a boiling point of 58.8 degrees Celsius, at which temperature is bromine a liquid. Bromine element exists as Br2 molecule. Any substance would be a liquid between its melting point and boiling point. Above 58.8 degrees Celsius, bromine would exist as a gas. Below negative 7.05 degrees Celsius, bromine exists as a solid, and between the two, it exists in the liquid state. Since the melting and boiling points are given to us in degrees Celsius, we need to convert it to Kelvin. To convert to Kelvin, just add 273 to the temperature in the degree scale. The melting point in Kelvin is 265.95 Kelvin. And the boiling point is 331.8 Kelvin. Between these two temperatures, bromine is a liquid. So any of these choices which falls in this temperature range, that's 300 Kelvin, bromine would be a liquid at that temperature. Which of the following occurs as steam condenses to water? I've pulled up a heating curve here, which is really useful for us to understand how to do this question and the question following this. A heating curve is a plot of the temperature versus time. It shows you how the temperature of a substance changes as heat is added at a constant rate. So if you start with the substance below its melting point, it will begin as a solid. As you increase the heat, the particles will absorb the heat and start vibrating and moving more faster. This increases the kinetic energy, and when the average kinetic energy increases, temperature increases. So the solid's temperature is increasing here, and once it reaches its melting point, the solid starts melting. Here you need to note that during any phase change, whether it's melting, boiling, or the reverse, condensation or freezing, the temperature stays constant at the melting point or the boiling point. This is because during a phase change, there is no increase in kinetic energy. The added heat is used to overcome the interparticle attractions so that the solid turns to the liquid or the liquid turns to a gas. Further addition of heat will be used to increase the kinetic energy of the liquid particles. They move faster and hence their temperature increases. When the temperature of the liquid reaches the boiling point, the liquid starts vaporizing into the gas, temperature staying constant all the way, as the added heat is used to overcome the interparticle attractions in the liquid so that they can pass on to the gaseous state. Further addition of heat will increase the average kinetic energy of the gas particles and the temperature of the gas increase. So wherever you have a phase change, the potential energy is increasing, kinetic energy stays constant, temperature also stays constant, and when the temperature is increasing, the kinetic energy increases and potential energy stays constant. So if you begin with a substance above its boiling point, it will be in the gaseous state. Cooling it will decrease its temperature as the particles will be moving slower and their kinetic energy will begin to decrease. Once it reaches its boiling point, it would start condensing. The phase will change from gas to the liquid. As temperature is staying constant, the kinetic energy is constant. And since the attractions between the gases is increasing as they turn into the liquid state, there will be a decrease in its potential energy. Once all the gas has turned to the liquid, further cooling would decrease its kinetic energy as the particles of the liquid will be moving slower. Once the liquid reaches the freezing point or the melting point, the liquid starts turning into the solid. Attractions increases, potential energy decreases. Temperature is constant, so kinetic energy stays constant. Once all the liquid turns to solid, further cooling would decrease the average kinetic energy as the particles would be moving slower now. The temperature decreases and the potential energy stays constant. If you observe the pattern in a cooling curve, the energies are either decreasing or staying constant. If there's a phase change, kinetic energy is always constant. And when temperature decreases, kinetic energy is decreasing. Now to our question, which of the following occur as steam condenses to water? Kinetic energy of particle increases. There is no energy increasing in a cooling curve. So cross that out. The distance between the particles increases. It's a cooling curve, so they are coming closer and not increasing. Temperature remains constant. During condensation, during any phase change, whether it's a heating or a cooling curve, temperature does remain constant. So it's just 3 only. Which of the following graphs best represents the cooling curve when a pure substance with a melting point of 50 degrees is cooled from 75 degree to room temperature? Here the substance is starting at 75 degrees. So all these graphs, they start at 75 degree. And you want to cool it all the way to 25 degree. That's where all these curves end. We've seen in the previous question that during any phase change like melting or boiling, the substance stays at constant temperature. Only in the choice A does the temperature stays constant at 50. In the other choices, temperature isn't staying constant during the entire phase change. So the right choice is A. Which of these changes of state is endothermic? All the changes of state that goes in this direction, that's solid to liquid, liquid to gas, or solid to gas, absorbs heat, and that's endothermic. All the changes of state that goes in the reverse direction, gas to liquid, liquid to solid, or gas directly to solid, is an exothermic change because they release heat or they do so on cooling. A gas to liquid is exothermic, not endo. Solid to gas is endo. So that's a choice. Liquid to solid is again cooling, so that's exo. That's not our choice. And this is not a change of state. This is the combustion reactions. All combustion reactions are exothermic. This is, let's say, an atom of hydrogen. And let's say this is an atom of oxygen. This would be a molecule of the element hydrogen. Because you have two atoms of the same type, it's still an element, but because you have a group of atoms bonded together chemically, that's why it is a molecule. This is a molecule of the element oxygen or O2, and it's still an element because it's made of the same atoms. It's not a compound. Here we have two hydrogens and one oxygen atom, and they're bonded chemically. Now this is a compound. This is another compound, CH4 or methane. The black sphere represents carbon and each of the white spheres represent hydrogens. So this is a compound because it's made of more than one kind of atom, carbon and hydrogen, bonded to each other. So a compound consists of an atom of the same element. This is wrong. They should have atoms of different elements chemically bonded together and not physically bonded together. The chemical bond would be either an ionic bond or a covalent bond. In a compound, the elements are present in a fixed ratio. This has to be correct. If this is a molecule of water, this is H2O. We have only one oxygen bonded to two hydrogen. This is H2O2, where you have two oxygens bonded to two hydrogens. So they have to be bonded in a specific ratio. If they're not bonded in the right ratio, they would be atoms of different elements with completely different chemical and physical properties. The elements of a compound can be separated by physical methods. No, you cannot. You can use physical methods to separate the components of a mixture, but to separate elements of a compound, you will have to do a chemical reaction or a chemical method. Thin layer chromatography can be used to analyze amino acids in pharmaceutical industries. Which of the following amino acids have an RF value of 0.5? Thin layer chromatography is a technique used to separate components of a mixture. The components of a mixture is subject to a competition between two phases. You have a stationary phase. In this case, the stationary phase is a paper, and a mobile phase. Here, the mobile phase is water or ethanol or the liquid that is used in the experiment. Draw a line with a pencil close to one end of the paper and spot the mixture on the pencil line. Hang the paper vertically and dipping it in the solvent, making sure that the level of the solvent is just below the pencil line. The solvent rises up the paper due to capillary action, dissolving the mixture with it. Each component of the mixture having different solubilities in the solvent would get separated based on the solubilities. The component that is more soluble in the solvent rises up further, with the least soluble solvent trailing behind. Thus, a separation is effected. The components can be identified by their RF factor. The RF factor of a component is the distance moved by that component over the distance moved by the solvent front. So if the solvent has moved up to this level, and this is 0 centimeters, distance moved by the solvent front is 7 centimeters, and the RF factor of component A will be 6 centimeters over 7 centimeters. The question is asking which of the component has an RF factor of 0.5. So in order to get 0.5, the component must have moved 3.5 centimeters. So that 3.5 centimeters over 7 is 0.5. So that's component C, amino acid C. Select an appropriate method for obtaining crystals of potassium chloride from its aqueous solution. Potassium chloride is soluble in water, so it forms a clear aqueous solution. Separation by solvation and filtration is a method of separating insoluble substances from their suspension in water. For example, you make sand in water and then you filter out the sand particles. So B and D are not the right choice. Paper chromatography, we cannot use paper chromatography as there is only one solute in the solvent. Simple distillation is when you distill out the lower boiling substance, that is, distill away the water, followed by recrystallizing potassium chloride. So the best option is A.